Hello to everyone. So today I will present you a project that we have done with Server for Linux, which was integrate Jammy in Yocto and run it on an i.MX6 and more particularly on a codec i.MX6. So I entitled my presentation How to Bring Fully Distributed and Secure Communication Capabilities to Embedded Products and IoT. Because Jammy is focused on communication security, and we think that this is very important in today's IoT and embedded products communication that there is more and more security. So a little word about me. So I'm a junior embedded engineer at Server for Linux, and I'm basically working on creating custom Yocto BSPs, and I'm also working on media's camera integration, etc., etc. Well, I will start with a little presentation of Jammy and why we wanted to do this project. Then I will present you, well, our work on the Yocto integration and the run on the i.MX6, and I will finish with a little demonstration. So let's start with what is Jammy. So Jammy is a communication tool developed by Server for Linux. It is available on Windows, macOS, and standard Linux distribution like Ubuntu or Fedora, but also on smartphones. Jammy is a free and open source audio, video, and text peer-to-peer communication platforms. It does not require a server and implements distributed and secure end-to-end encrypted communications. Moreover, this distributed architecture offers private life protection on the internet. So Jammy is intended for mainstream users as well as professionals. And recently, Jammy has implemented some new and interesting features. One of the main is the video conferencing, like you can see here, and that's it creates the possibility to have a large group of participants on the same call. And there is also the possibility to create rendezvous points. These are accounts that can be called at any time, even if the creator is absent or in another call. And also to finish, Jammy's team developed Jammy Account Management Server called Jams. And Jams allows you to create and manage your own community of Jammy users. So let's now continue with why adding Jammy on an embedded board and why we have done this project. So adding Jammy on an embedded board creates the possibility to have secure communication and private life protection on all kinds of devices. You all know that in today's world, more and more objects are connected to the internet, and the technology of IoT is growing. So these new multimedia communication are not confined to smartphones and laptops, but are new used to in like personal assistant, connecting read bells, baby phone, and much more. So that are everyday life objects. So the security of this communication is very important for our private life. And Jammy therefore fits into this objective with its serverless, distributed, and secure end-to-end encrypted communication. We also could think about a network of CCTV, a mesh of large volume of sensors, a fleet of robots, etc., etc. And thanks to Jammy's distributed architecture, it allows you to manage a large volume of sensors, exchanging data in a secure environment. But well, another reason why we could consider adding Jammy on an embedded device is because nowadays the embedded resources have notably increased, and they now include hardware codecs and are being able to run Jammy without too much CPU consumption. Nevertheless, we were not sure if Jammy could run on an i.MX6, and that's why we have done some tests before starting the project. First, to be sure we could run a Qt application, we wanted to add cinematic experience, which is a Qt5 demo application, and we were able to run it with less than around 10% of CPU. In order to get closer to the final usage and evaluate the performance of the i.MX6, we have done some tests with and without this hardware codecs. So we have streamed a camera over the network after encoding it in H.264. And the result was without hardware acceleration, we got a CPU percentage of around 90% and a reception of almost 0 frame. But with the hardware acceleration, we reached a CPU percentage of around 7% and no loss of frame. So with this result, we could imagine run Jammy on the i.MX6. But well, it was still a challenge because we still need to control all the chain in order to have good performance. And this is why we choose to integrate Jammy in Yocto. So let's now talk about the integration of Jammy in Yocto. So the goal was to integrate Jammy without significant Jammy source code modification in order to easily integrate any updates and also not to stray too far from the original source code. And that could generate lots of source code modification, and we didn't want to have lots of maintenance for the embedded parts. So at the end, the goal was to be able to create an account and call any other Jammy user as if I were on a standard Linux distribution. So we tested our work on the codec Apalis i.MX6, and running Jammy on such embedded boards opens the opportunity to run it on other embedded boards and on every platform supported by Yocto. And this could be easily possible because Yocto is very modular and organized in layers, and the already created layer could be reused as a base for other platforms. And that's why we cut our work in multiple layers to fit in this layer, in this Yocto philosophy. So here is a diagram from that represents our work. So we created 3 different layers. The first one is called Jammy. Jammy wraps the application and all its dependencies. This layer provides the graphical application of Jammy, and it includes the backend daemon and the multi-platform Qt client of Jammy. So this layer provides Jammy for x86 applications, x86 architecture, sorry, and it contains the same source code as a standard Linux distribution. So this layer will also be the base layer to export Jammy for other architectures. So therefore, we created a second layer called Jammy i.MX, and this second layer provide Jammy for the i.MX6, and it contains the FFmpeg work that I will present just after, the library that we have used, and the only source code modification that we have made. This layer could be reused to use Jammy on other i.MX6 based embedded board. And finally, we created a last layer called Jammy i.MX codec, because the main purpose of our work was to port Jammy on a codec Apalis i.MX6 board. Consequently, we created a layer that provides a machine, a distro, an image, which include Jammy to run on Apalis i.MX6. So this layer is a layer ready to use. Our work has been tested on a codec with a codec kernel based on the FreeScale one, but we could easily imagine using a mainline kernel, and it's work that we are planning to do in the proximate months. Sorry. So let's now switch on the FFmpeg work. So FFmpeg is a cross-platform tool used to record, convert, stream audio and video. And FFmpeg libraries are, for example, used in the famous media player VLC. In order to perform a call, we need to use the hardware codecs, the encoders and decoders present on the board instead of software ones. Without hardware acceleration, all video encoding and decoding operations are executed on the CPU. And you all know that video compression and decompression are complex algorithms that generally cannot be executed in real time on CPU cores, as we demonstrated with our test that I presented you earlier. So therefore, using software codecs would make Jammy unusable. And as Jammy is based on FFmpeg and it does not support i.MX hardware codecs for a free-scale kernel, that's why we applied some patches to FFmpeg to include this codec. So we added an H.264 encoder and decoder for sending and receiving video, as well as an MPEG decoder to support some camera output format. In order to add them, we based our work on the community API, lib.i.MX VPU API, that provides the control of the i.MX VPUs. This API is already used in GStreamer i.MX, for example. In addition, the only Jammy source code modification that we have made is to use this hardware codec, the hardware encoders and decoders of the i.MX6. So we reached our objective, which was to have the less Jammy source code modification. So to finish, I will just do a little demonstration of Jammy on the codec i.MX6. So if I can switch the sharing here. Oh, that's not a good resolution, but well, we could imagine something. All right. So if I can call with my own Jammy on my computer, we see that you receive the call. And here you can see me. I can go in the full screen, but well, there is a black screen at the top because I was rid of cameras for this demonstration. So well, of course, it's working. There is also the sound that it's working, but well, on the presentation, that's difficult to record the sound. A little word about well, the performances, etc., etc. So we are around well, 30% of CPU with the Qt application and the backend daemon. Well, of course, we have to there is still work to be done. And well, because it's a proof of concept, we wanted to show that it is possible to run Jammy on an embedded board. But well, there are still work to do. The work to do is, well, have better performances, of course. And there is still some format change that is still done in software that we want to do it all in hardware to accelerate the application. And of course, the mainline kernel support. So let's back to my presentation here. All right. So well, I hope you will enjoy my talk, and thank you for listening. If you have any question, I will be pleased to answer them.